2. Xin mời nhóm số 2.
Đưa xe vào chéo đường với con cua xong.
Hi everyone, and thanks for joining our presentation today. My name is Hoàng Duy Phúc, and these are my mates Nguyễn Ngọc Bảo An, Huy Chi, and Minh Hoàng. We are all from the STEM Club, and today we'd like to discuss about our latest STEM project, the agricultural robot. First, let's take a deep dive into our engineering design process. First, we've detected the problems that has coexisted along with the world. Secondly, we've researched and studied foundational knowledge that has existed beforehand. Thirdly, we've proposed adequate design for the project. Fifth, we've fabricated a model that is also adequate for the project. Sixth is the experimenting and assessing time. Seventh is to modify the aforementioned design. And finally, presenting and discussing, which is what we're doing today.
First and foremost, our club has assessed the current situation in order to detect the most critical issues that occur in agricultural production. Such difficulties are labor shortage, increasingly high labor costs, irregular harvestation, and farm produce loss and waste. According to the Ministry of Agriculture and Rural Development of Vietnam Statistics, in 2024, Vietnam incurred billions of VND annually in fruit tree cultivation due to delays or mistakes in harvesting process. Therefore, researching and developing a smart and reasonable solution to automate fruit harvesting is extremely necessary. That's the reason why our club agreed to invent the agricultural robot. Our project is developed based on foundational knowledge that we acquire from particular school subjects. Firstly, we acquire knowledge from natural science, such as electric circuits, sources of electric currents, and sound wave. Secondly, mathematical knowledge is used in calculation and measurement. Along with that, computer science is applied for searching information on the internet and coding. Finally, we use computer science for assembling models. After some discussion, we finally reached a problem of the ideal design. The fruit harvesting robot is designed to be both autonomous and remotely controlled, integrated with monitoring through sensors and camera systems to perform tasks such as detection and collection. The operator principle is divided into specific parts.
Next is the fourth step, selecting the solution. To design and develop our project, which is the agricultural robot, we applied the following research methods. First is the documental research. Our club searches, analyzes, and applies interdisciplinary knowledge from subjects such as mathematics, computer science, technology, and nature sciences, and uses information related to the product from books, newspapers, and websites. Next is the experimental method, which we programmed and tested the feasibility of the model. Finally is the synthesis and analysis method. We evaluated and proposed optimal solutions based on research and experimental results.
Let's move on to the fifth step. The Bluetooth gamepad connects to the cyberpad control board on the robot via Bluetooth, allowing the control of the motors and enabling the robot's movement. The main control buttons, which are on the gamepad, are used to move the robot in various directions: forward, backward, left and right, as well as to perform actions such as grabbing, releasing, lowering, and lifting. Flexibility is provided because the user can navigate the robot through complex terrains, such as the fruit orchards, ensuring that the robot reaches the exact position needed for harvesting.
Next, to craft the robot, we've obtained some accessories such as the PS2 controller, the Arduino circuit, the ESP32 circuit, the servo turbo, and the ultra sensor. After collecting all the accessories, we proceeded to craft and code the robot in success, thus creating our products today. Next is how the robot works. First, the PS2 controller controls the robot to move, while simultaneously sending videos onto the web server and also checking the shape and colors of the fruits. After checking, it will send data on the web server, after which the user will then observe the web server and we can finally harvest the fruits.
Then about automatical harvesting and wrapping system. The harvesting arm mounted on the robot is equipped with a flexible gripper that can detect and secretly grab the fruit when the robot detects a
Go on.
Next one, remote observation and monitoring via camera helps collecting data with sensors and remote monitoring. The sensors mounted on the robot distinguish between ripe and unripe fruit, then send the data to the CyberPi. The CyberPi directly commands the robotic arm and to harvest only the ripe one. Besides, the camera allows users to access real-time images from the robot via a computer or smartphone, helping them assess the situation and make informed decisions.
The next systems are the sensor and alert system. First one is the fruit detection sensor or the color sensor. The robot uses a color sensor to to identify the distinctive color of ripe fruits. For example, orange for oranges and red for apples. When the fruit is detected to be ripe, the robot activates the harvesting arm. Next is the distance sensor or the ultrasonic sensor. The distance sensor detects the distance between the robot and the plant, ensuring that the robotic arm approaches accurately without harming the plant whatsoever.
Next, about the tag collection and display of CyberPi. Display sensor data, harvest location and status. Display information about the number of fruit harvested and the status of the robot. Garden environment includes soil moisture, the distance between the robot and the surrounding plants. Instant alerts. When anomalies detect an alert, the system will trigger an alert, allowing manager to take immediate action. Moreover, Scratch plays a role in controlling the robot's movement, connecting to the controller for remote operation. The main steps include, first, connecting the Bluetooth controller. The Bluetooth controller code is used to communicate with the Bluetooth controller through the code upload connection on the CyberPi.
Next is controlling the motors and grab and release mechanism. The last feature is ultrasonic camera, with which it will connect with the color sensors to which it senses and interprets data, then measuring distances and transmitting images through the CyberPi connection. After inserting the codes into the CyberPi, the codes will be stored into the project area.
The next part is experimenting and assessing. First one, experimenting. Flexible remote control. The operator changes the distance with the robot with a maximum of 10 meters and the robot will receive a signal from the operator. Harvesting system and distinguishing ripe fruits. Accurately harvest ripe fruits, the robot's arm reacts flexibly to secretly grab the fruit when the robot detects a ripe fruit.
The following tests are on the remote observation via ultrasonic. The real-time images and wide flexible viewing angle can monitor the entire surrounding area, including blind spots that the naked eye usually can't spot. The camera can also rotate or adjust the focus on specific that needs supervision. Fourth is the real-time monitoring and alert system, which includes the shape and color sensors, automatic alerts, and continuous reporting feature, which can be annoying at times.
The automatic detection and troubleshooting system not only have saved time, but also removes damaged fruit and minimizes the risk of accidents during the harvesting process. Our project scalability and development includes integration of additional sensors and development with AI. In the last section of our engineering design process, we have assessed the project's result and ability of development in the future. The fruit harvesting project was developed to address one of the pressing issues in modern agriculture, optimizing the harvesting process and reduce reliance on manual labor. By using advanced technologies such as Arduino, image process systems, and modern sensors, the harvesting robot has been developed with the ability to operate accurately and efficiently in real-world environment.
Result assessment. Through the development and testing process, the project has achieved promising results. Recognition and harvesting feature, flexible robot arm, supporting sensors and remote control feature.
Second, and the final part of our presentation is the future development of the fruit harvesting project. This has great development potential with many upgrade directions to improve efficiency and expand its applications such as full automation, upgrading the AI system, improve danger detection capabilities, enhance communication features, and finally the development of a multifunctional robot model.
That's the end of our report.